So on number 21, if they want you to write the function in vertex form and identify the vertex, what we're going to have to do is take that standard form equation, convert it to vertex form by completing the square, because you cannot factor it. So the first thing to do is to rewrite it and leave space for your new C value, your new perfect C value. Now normally I would take the -2 and add 2 right here to cancel it out, and add 2 over here if I were solving an equation, but I'm not solving an equation. This is a function, so I don't want anything with the f of x. So that's why I just moved the -2 over a little and left space for my new C value. Now let's do the process called completing the square. We're going to take the B value, which is -6. We're going to take half of it, and that's -3, and then we're going to square it, and that'll give us a +9. Now you can't just magically add 9 to one side of the equation. You either add it to the other side of the equation to maintain the balance, but we don't want to do that because we don't want to mess with f of x. So since I added 9 to one side, I'm also going to subtract 9 on that same side. I know what you're thinking. Why would you add and then subtract 9 on the same side? That's just to keep it balanced, okay? Now, the truth is, what we have right here is a perfect square quadratic trinomial, and that could be rewritten as a binomial squared, and the -2 and the -9, you could just combine them together and have them as a k value on your vertex form equation. So what belongs on the inside of the binomial squared? The x and half of b, which is a -3. So whatever the b is, right here it's -6, the half of it's -3. If it were a +12, it would be a +6. If it were a -8, it would be a -4. If it were a -22, it would be a -11. So it all depends on what your b value is. Inside of the parentheses, you're simply going to take half of it. So what do we have? We have our vertex form equation right there. We're done. Any other? And let's identify the vertex. The vertex will be +3, -11. You simply think opposite on h and take k for what it is. To write the function in vertex form, identify the vertex, we have a standard form quadratic trinomial equation. We need to write it in vertex form. There's a couple of ways of doing this. I'm going to do it both ways. I'm going to do it by completing the square. Very first thing is, in order to complete the square, you need to have space for your new C value, and also your A value has to be 1. So first, I'm just going to rewrite it, and I'm going to put space for my new C value. Now normally what I would do is I would get rid of the 4 by subtracting 4 and subtracting 4, but I don't want to mess with f of x. That's the name of it. If I were solving an equation, yeah, you mess with both sides of the equation. You mess with this side, you mess with that side, but we're not solving an equation. We're just changing the form of f of x. So I don't want to mess with f of x. So that's why I just pushed the +4 over to the side and made space for my new C value. So I need to get the A value of 1, and as you can see, the A value is -2 right now. So again, if it were an equation that I was solving, I would divide by 2, divide by 2, divide by 2, divide f of x by 2, but I don't want to mess with f of x, so I don't want to divide everything by 2. What I'm actually going to do is factor out a -2, and if I factor out a -2, I'll actually have an x squared. I will have a +8x, and then the space, and guess what? I'm going to close the parenthesis, and I'm going to leave the +4 out here at the end. And just for the sake of making it look nice, let me close the parenthesis with blue. So you're probably saying, why did you leave the 4 out there? If I would have factored out a -2 from the 4, I'd have the 4 inside the parentheses, and I don't want the 4 inside the parentheses. I want a perfect square quadratic trinomial. That's the whole purpose of completing the square. How do I complete the square? 8, take half of it. What's half of 8? 4. Square it? 16. So I'm actually going to add 16 inside the parentheses. Now it looks like I am adding 16 to the right side of the equal sign. So but the thing is, we're not really adding 16 to the right side of the equal sign. By me putting a +16 in here, what I'm really adding to this side of the equation is -2 times 16. So I'm really throwing in a -32 in there. I'm really throwing in a minus 32 in there. So in order to balance it out, I would have to add 32 to the same side of the equation. Is that kind of confusing? Yes, it is. But anyway, we now are able to factor the quadratic trinomial on the inside and change it to a binomial squared. The 4 plus 32 is 36, and the a value is negative 2, and the inside binomial will be your x and simply half of b, which is 4. And believe it or not, we are done. F of x equals negative 2 parentheses x plus 4 squared plus 36. That's your vertex form equation. Now, if you're thinking, man, I'm getting confused with this 16 and then 32, what is that? All right, if you're totally lost on this problem and they want you to rewrite it in vertex form, there's another way of doing it. When you want something in vertex form, you need to know that that is y equals a parentheses x minus h squared plus k. So if you know your a value, your h value, and your k value, then you'd be able to write the equation in vertex form. By looking at the original equation, do we see an a value? Yeah, what is it? Negative 2, that's right. So we know that the a value is negative 2. So all we need is an h and a k. If we could find those values, h and k, we'll be able to write the equation. So by looking at the original equation, could we find an h and k? We need to remember that h and k is the vertex. So technically we could find the vertex by using this, x equals negative b over 2 times a, right? So if I did use negative b, which is negative 16, over 2 times a, which is 2 times negative 2, we'd get positive 16 over negative 4, and that would equal negative 4. What did I just find? I found x. X equals negative 4. And we're talking about x inside the vertex. So that's negative 4 for x. Now if you need y for the vertex, you simply plug it in and work it out. Now let me move, where should I move? I want to move to the actual function, and I'm going to rewrite the function but with parentheses instead of x values right above it. There is the function with parentheses instead of the x's, and we're going to plug in the negative 4 into those parentheses. So we're going to put a negative 4 right there. We're going to put a negative 4 right there. And if we were to work it out, when we take a look at negative 4 squared, that's 16. And 16 times negative 2, that is negative 32. That's my first term. And then if I take a look at negative 16 times negative 4, that's going to be a positive 64. Sorry, I'm writing all over this thing. And last but not least, a plus 4 at the very end. So if we actually did this, negative 32 plus 64, that's 32. And 32 plus 4, that would give me the y value of 36. So what did I just find? I found the y value of 36 on my vertex. So now that I know my vertex, I really know my h and k value. So I actually have my h value of negative 4, my k value of 36, and now that I know my a, my h, and my k, I could all plug it into my a, my h, and my k, and I would get the same exact answer as the answer I got over there by completing the square. Does that make sense? Moving on to 23, domain and range. Ladies and gentlemen, domain and range is going to haunt us forever. Domain is x, range is y, right? Domains are your x values, range is your y values. We know that the quadratic trinomial equation right here on number 23 is a parabola. We know it's opening up. We need to get a visual first before we talk about domain and range. On any graph that you want to talk about domain and range, you want to find the most important point, and this parabola has the most important point, the vertex, and we need to find that vertex, and we're going to do that by doing x equals negative b over 2a. X equals negative b over 2a. Let's plug in the values with parentheses. negative negative 8 over 2, which is positive 8 over 2, which equals 4. And that is your vertex x value of 4. And if you want your vertex y value, we'd have to actually plug it in and work it out. So what I'm going to do is take this above f of x function and rewrite it, but with parentheses instead of my x's. The 4 with parentheses, as you can see right there. So there's a 4 right there and a 4 right there. And when we work this out, 4 squared is 16. 8 times 4 is 32. So you have 16 take away 32 and a plus 12 at the very end. And if we just go from left to right, 16 take away 32 is negative 16. Negative 16 plus 12 is negative 4, correct? All right, so our vertex is 4, negative 4. So again, if I want to state the domain and range of any function, you find the most important point. In this case, it's 4, negative 4. So you do need a quick sketch of where 4, negative 4 is at. 1, 2, 3, 4, 1, 2, 3, 4. So it's down here. We know that this parabola opens up because the a value is 1. And we know that it has the pattern 1, 1, 2, 4, 3, 9. But that's not even that important. Right now, we know that it's opening up. And let's think about the most important point, which is 4, negative 4. The most important point, 4, negative 4, has an x and a y within that coordinate. The x value is 4, so I'm going to put it over here where the domain is at with the x. The y value is negative 4, so I'm going to put that negative 4 up there where the range is at with the y. Now the question is, what inequalities belong within or between the x and the 4 and the y and the negative 4? So if we think about the x value first, which is going right through the x value of 4, is the parabola on this side of the x value of 4 or on this side of the x value of 4? It's on both sides, right? So since it's not less than 4 or greater than 4, it's both, you're going to erase the 4 and actually put x equals all real numbers. So that's exactly what I'm going to do. I'm going to scratch out that 4 and say x equals all real numbers. You could use the symbol for the domain x equals all real numbers. Now what about the range? If we think about the range, let's go to the y value of negative 4, which is clearly right here, the y value of negative 4. And the question is the parabola, is it above the y value of negative 4 or below the y value of negative 4? It's above, which means that it's greater. And that's the inequality symbol that you're going to put right there. Y is greater than or equal to negative 4. So the domain, x equals all real numbers. That's another important thing to remember. Any domain of any parabola, whether it's opening up or down, whether it's wide or narrow, doesn't matter. Any parabola is going to have the domain x equals all real numbers because it goes both left and right forever. The range, on the other hand, you have to think, is it above the y value of negative 4 in this case, or below the y value of negative 4? So if it's above, you write greater than. If it's below, you write less than.